we have got a overwhelming response feedback from the faculty. We are very happy for that. And some of the faculty had noticed that they are facing difficulties with the software. I think so. Yes or no? Can you please respond? Some of the faculty had given the feedback that they are facing with the implementation in software. Yes or no? Installation and flow. Installation of the software. Is that correct? To resolve that issue, we are going to share a small resource video, and we like documentation for step-by-step installations, step-by-step installation process of software. We are going to share the video file and document to you after by end of the session. So it may be helpful for your software installation software process. Okay. And in morning, I have posted the assignment document in the group. So by the end of the day, you will receive a form. You will receive a Google form to upload your completed assignment. So please upload your assignment file there. Okay. Is that clear, my dear faculty? Yeah. Thank you. Thank you so much. Without any further delay, we'll start the session straight. I will hand over the session to our resource person, Mr. Tejesh. And meanwhile, if any one of your colleagues have enrolled for this program but not yet joined, please ask them to join. Okay. Thank you so much. Thank you so much, my dear faculty. Tejesh, please carry on.
Yeah, Surya, thank you. I will share my screen. Yeah, I think my screen is visible to you all. Yeah, Friday, I think I did not show the output of JK flip-flop, including the frequency division. Yeah, end of the session, we will tell about that the timeline of the assignment, okay? So I did not show the output of including the frequency division of the JK flip-flop. So now I will show it, okay? Because of because of the problem is the bit file is not updated in that same folder. Okay, now I will show it. Open hardware. Open target, auto connect. So now we can create on the background. Yeah, program device, program. So now we are successfully done this one. So now I will on my cam and we will check our output. So I think the screen is visible to you all. Yeah. So this is the J and the K. So now we are giving this is the 0 0. For the 0 0 there is no output. For 0 1 still there is no output. For 1 0 1. Okay, for 1 1. So now we will observe this kind of toggling condition. Now, but why? For the what is the difference between the previous one and this one? So now we are adding the frequency division concept here. See, now we are adding the frequency division concept, same code. See, there is no error in that code. Okay, the file is not up, the bit file is not updated in the previous folder. Okay, so that's why I'm changing the folder. I'm changing the file program folder. Okay, that's it. So this is the JK flip flop toggle condition to verify the JK flip flop on FPGA board. Okay, so this is the total information. You can do any kind of sequential circuits. You can repeat the same program. You can change the JK flip flop. That's it. You can change the JK flip flop with replacing of counter. You can do mod 10 or whatever it may be, a ring counter, twisted ring counter, any kind of circuits, no problem. Okay, that's it. Now we are discussing about the LCD. Okay, so the what is an LCD? In the these kind of LCD will be shown the different character outputs. I'll close this file and I will open the LCD code. Open the project of LCD FPGA. Yeah. because of I will parallelly explain the theory and how I am writing the LCD code. Okay, so first of all we are discussing about the few things about LCD. So what is LCD and how it will be, we can do it, and we are discussing about the block diagram of so how it connected to the FPGA board. Okay, yeah. So now coming to this LCD liquid crystal display. We know I think all members are know the name very well. Liquid crystal display, we can call it as LCD. The common name we can call it as 2 into 16 LCD. The common name. Why we can call it as 2 into 16 LCD? Because of in LCD we have two lines. Okay. For each line we can write the 16 characters. All of you. For each line we can write the 16 characters. So totally we have to write, I mean we need to write, I mean totally the LCD to display fit, I mean the LCD fit to display the 32 characters. Okay, for two lines. For each line it will display the 16 characters. So this information I think you people are know about it very well. But now coming to the block diagram of FPGA, interfacing of FPGA and LCD. How, see, this is very simple diagram. I will draw. This is our FPGA board, whatever it may be. Okay, but few FPGA has definitely the block diagram will be changed. This is the LCD. Okay, so from here we need to connect the 4, 5, 6, 7, total 8 pins. See, D0, D1, D2, D3, D4, D5. I will zoom it. D6 and D7. Total 8 data pins. Okay, total 8 data pins. Total 8 data pins. Why, sir? Why 8 data pins? Because of, it will store the 16 characters of each line, but each character, I mean, for one character, we need to write the bit 8-bit. Okay, so that's why they have 8 data pins. I think you people are understood. Suppose, I mean, for example, I want to send the T character. See, I want to send the T character. T. From example, I'm writing the example code of T in my Edge RTX 7 FPGA board. See, in this Edge RTX 7 FPGA board, I'm examply write the T character. So I want to send this T character to display, to write on LCD, to write on this LCD. Okay, I want to display on my the LCD the T character. So we can't directly write that. So we need to send the 8-bit code for the T. Okay, we need to send the 8-bit code in binary, or you can write in decimal. Suppose the 1011. So this is the 8-bit code for T. Suppose, for example, this is not a original one. Just we have taken and this is an example. Okay, or otherwise you can write like this also. 8 decimal. This is the 9, I think. Yeah, 9. So you can write like this. This is the 1101. I think. I mean, just a minute. This is the very longest number. 0101. Okay, this will go. But I mean, I'm taking the only example number. Okay, no need to worry about it. So this is the 5. You can write like 95. Okay, you can write like this one or this one also. There is a lot of possibility, all of you. For this kind of FPGA board has, see, for H RTX 7 board, has 8 data pins. You need to directly connect the 8 data pins, of course. But the LCD has control pin is also there. They have 3 control pins. The first one is LCD enable. The second one is LCD register select. And of course, the third one is LCD read or write. Okay, don't worry. I will write it again. How, see, this LCD enable and LCD register select. This RS means register select. Okay, register select. Of course, this is LCD enable. Of course, the third one is RW. That means read or write. Okay, read or write, or you can call it as write or read, whatever it may be. So these are the control pins. These are the control pins. Okay, these are the print the data, but these three are control pins where we have to print the data. On which format we need to suppose, sir, why we want this control pins? Simply, suppose we need to print the the character here. I want to print the T character here. So we want to select the first line. See, we want to select the first line use the control pins. Using control pins, we need to select this first line. Okay, I want to start from the left side. Simply, just a minute. Yeah, I want to select from first line from the left side. I don't want it from this side. Okay, I don't want the second line also. So we need to use this control pins for this kind of commands. Okay, I want the T character on first line, first character. I don't want the first line last character or second line first character also. Okay, so you need to give this kind of comments using this control pins. Sir, okay, for three, how did you define that these three are main control pins? What is the working of this control pins? What is the working of this LCD enable, LCD register select, and LCD reader write? For that, before we need to discuss about one point. See, this is the main point. This one is very main point. For Edge Arctic 7 FPGA has these 8 data pins. For you can take the Spartan 3. Suppose I am taking the Spartan 3. See, Spartan 3. But for that FPGA board, there is a little bit difference is there. They do, I mean, there is no 8 data pins, only four pins. There is only 4 data pins. I mean, control pins are common. Okay, there is, I mean, there is a 3:0 pins are unused. We did not use the 3:0. I mean, remaining 4 pins are unused. The control pins are common. The control pins are common on that Spartan 3, but there is only 4 data pins in Spartan 3. Sir, but here we have 8-bit data, sir. Here there is only 4 pins are available in Spartan 3, but how can we send the data? I mean, is this possible? Yes, it is possible. See, for 8-bit, for the T character, what is this? 1011 or 0101? 1011 and 0101. See, this is the 8-bit code of T character. So we need to send this, we can call it as upper nibble. And this one, the second one, we can call it as lower nibble. Okay, lower nibble. So for the first 8-bit code, we need to send this upper nibble. And after some time, after the 20 nanoseconds gap or 2000 second nanosecond, there's some time calculation is there between the 4 pin data bits. After we need to send this 0101. That's it. This is only for, I mean, this 4-bit, this 4 data pins is only for Spartan 3. I don't know about the remaining boards, but Spartan 3 has 4 data pins. And you can use any kind of Edge Arctic 7 or Nexus A7 or Basis 3 or Edge Arctic 7. So these boards are remaining common. Because of why these have 4-bit, sir, why this board only contains the 4 data pins? Because of the inbuilt LCD. The Spartan 3 contains the inbuilt LCD. Okay, these boards are not like this. Okay, these boards are not like this. Okay, now coming to our edge board, all of you. Now we need to detail. Now I'm easily explaining this. What are the work of the control pins? Okay, what are the work of the control pins? I will explain. There is no much of theory. Just you need to listen these 3 things. Very easy. Okay, suppose LCD enable. I am giving the 0. The LCD will be off. If I am giving the 1, the LCD will be on. Now it will come to the LCD register select. Suppose now I am giving the LCD register select 0. It will give the commands. It will give the commands. Commands means, okay, you know what is the meaning of commands. Okay, you need to start from the left side. We need to start the cursor blinking. I want the cursor blinking. I want the cursor blinking, and I want the comments. I mean, I want to start from the first line. No, no, no. I want to start from the second line. So these kind of comments you have to give from the LCD register select 0. Okay, and you can give the one. This is the operation of write, read or write anything. Okay, this is the option of read or write anything. Now you can come into this one. If you can give the register select 1. See, it will come into the read or write anything. Suppose it will come into the LCD reader write. Now you can give 0. We will write LCD. I mean LCD RW 0. That meaning is write. If you can give 1, this is the read. Okay, this is the simple classification of LCD enable, LCD register select, LCD read and write. Sir, but in which kind of situation we have to do the LCD enable 1, LCD enable 0, LCD register select 1? See, this is not easy to on. You did not directly give these conditions. Okay, there is a procedure. We did not directly giving this. Okay, if we can give the LCD is code 1, that LCD will be directly, it not will be on. There is a procedure. Okay, there is a procedure. We have to give this kind of comments. Okay, this is the simple explanation of about the 3 control pins. What is the use of these 3 control pins? And of course, you people are know about it very well. 8 data pins. Of course, we need to send the 8-bit data to the LCD. We are using these 8 data pins, and these are the 3 control pins. Okay, so this is the total information of the LCD. I mean, but related, I mean, few more theories there. Okay, you no need to worry about it. This is the normal explanation of LCD. Now we will move to how can we implement it. How can we write the LCD code? Yeah. Now this is the LCD code. See, now I am open the LCD code. Total, this is the example name printing. Total code is, I think, yeah, 800 lines nearly. 882. Of course, 800 lines. The total LCD code for single LCD peripheral. This is the LCD printing. The total code is 800 lines. Okay, but no need to worry about it. This is not a big code. This is totally under comes to subject. The subject is very easy, but the code is too big. Okay, if I mean, I will explain it very detailedly. I will explain line by line. You don't need, no need to worry about it. Okay. Yeah. So now we are discussing. We will start. How I am write this code. Okay. See, up to here, I think no one have any kind of doubts. Up to this control pins and this theory, I think no one have any kind of doubts here. Hello. Anyone have any doubts here? Anyone have any doubts? If you have no doubts, we will continue. I mean, we will continue to the code. Okay. See this one. Coming to the PPT. Yeah. So our first step, we need to initialize the display. See, after the power on, the character LCD must be initializing this establishment required the communication protocol or sequence. I mean, I will show it. This one. Our first step, there is a total 3 steps of this code. I mean, the total code is 800 lines. I know it very well, but the code I am dividing in 3 parts. 3 parts. The first one is power on initialization. See, the what I'm writing, you need to, I think you can see this one, you can get more clarity for this. First one is power on initialization. Okay, these power on initialization will be decided the LCD on and off. LCD on and off, that means LCD enable related, this one. Okay, and the third one is display configuration. Display configuration part. See, I think you are observed that LCD register select commands. See, I want to start from the left side. I want start from the second line. I want the character on the second line. I don't want from the first line. So that will be selected by this. Uh, that will be decided by this display configuration. And third one is we need to write our name. I mean, print our name. Okay, print your name. So that will be automatically selected by the read. I mean, write condition. Okay. So now I want to write here, print your name. Okay. So this is the common code. Okay. So these are the 3 steps. So now our first step is power on initialization. See, the power on initialization have total 8 steps. In this power on initialization here, 8 steps. Here in this display configuration, they have 4, of course, 4 types. 4 types of display. I mean, I think here 8 to 10 steps is there. Okay, based on the FPGA. I mean, based on the FPGA, 8 to 10 steps. And here we need to write the 4 types of comments in the display configuration. And of course, your name, this will be depend this extension code. See, this extension code will depend upon your name. If your name is included the 6 or 7 characters, definitely your code will be extended. Okay, I will show it how to write this. Now we will discuss about the power on initialization. The power on initialization. See this one. Power on initialization. See. Yeah. So now see this one very carefully. In this power on initialization, this is the step 1. So wait least 15 milliseconds. Sir, where did you take these points? I mean, where did you take this point, sir? See, I am taking from the Spark. I mean, I will show it where I am taking these points. I will show the user guide on this one. Yeah, I'll show it because of this is the proof for you to write something about the LCD. No, not this one. Yeah, this one. Just a minute. Yeah. Function set. Yeah. So this is my base. I mean, see, I am taking this point from this guide. I mean, this user manual. Okay, this is my follow-up thing. Okay, this is my reference for the LCD research work. Okay, so this first point is I'll zoom it. Don't worry. This is the more zooming. Yeah, the first point is so the wait 15 milliseconds or longer to display generally the ready FPGA finishes configuration. The 15 milliseconds interval I want for the at 50 megahertz clock. See, this is the very important to show how I'm research work, how I'm research this one. So the 50 megahertz is the internal clock frequency of this FPGA board. See, of course, our FPGA board is also our FPGA board also is the 50 megahertz. Our FPGA board is also 50 megahertz. So they want the 50 millisecond interval. They want the 15 millisecond interval. That means they are directly given how the 750 clock cycles at this 50 megahertz. Okay, I will explain it. The 50 megahertz is you people are know about it very well. 20 nanoseconds. Okay, now tell me how much interval they want. How much interval they want? 15 milliseconds. So we need to convert into this 20 nanoseconds to 15 milliseconds. So the 15 milliseconds is nearly, I don't know, I mean, 15 megahertz, something 880 point something kilohertz we are getting. I mean, approximately. I don't know about it. But see, in this previous class, we are discussing about the frequency division. You know it very well. For the 50 megahertz to 880.8 kilohertz, I am using the total clock cycles are 75,000. I mean, 7,50,000 clock cycles. Okay. I mean, in the previous class, we are converting the 50 megahertz to 1 Hz. You people are know it very well. 50 megahertz to 1 Hz. We are getting the 25 into 10 power of 6 clock cycles. You know it. Same process here. See, same process. You need to take the output frequency is equal to input frequency by number of mod counts. You need to take the same process. Okay. So this is the input frequency. I mean, this is the input clock frequency. My FPGA. This is my input FPGA clock frequency, and this I want this output frequency. And but in this reference, they are directly given this 7,000. I mean 7,50,000 clock cycles. So now we need to write the code for this. I think you people are know yesterday. I mean, in the previous class, I am writing the how to write the code. Always at the rate of passage clock begin if of count is equal to, see, I am writing the previous code as it is, just I am changing the count. Okay, all of you, yeah, begin count is equal to 0. I mean else count is equal to count plus 1. That's it. Okay, this is the rough code of the frequency division. Now I will show it where this code. Just a minute, guys. Just a minute. Just a minute. Yeah, sorry for the. Yeah, so this is the rough code for the frequency division. We don't know, sir. We forgot that codes are completely. I mean, not completely. We know it, but we forgot a few things. See, now I will show this code. See, this is the LCD. I think these are the LCD frequency, LCD enable, and LCD register. Of course, 8 data pins. And clock and reset are common. You know it very well. Data means this is LCD data. Total 8-bit 8-bit data, 7:0. 8-bit data. And LCD enable and LCD register select. That's it. Okay. And of course, LCD reader write is also there. This command. We are taking this command for a LCD reader write. I mean, no need to worry about it. Okay. We are assigning this data to this one. I'll show where I am writing this one. See, all of you please see this one. See here I am implementing this code. This is the code of the frequency division or the first step of LCD. See, if of same code, just for few changes, LCD, we are adding the LCD enable, LCD register, both are 0. And count is 7,000, 7,50,000. And of course, count 0, we need to increment the state. Otherwise, we need to count the clock pulse. See, same code structure. Same code structure related to frequency division. Just one thing. For the previous one, we are adding the clock 1 H clock. That's it. Okay, as per the requirement. But now, as per our requirement, we want the state increment. If the counts is over, we need to increment to the next state. Okay, this is the LCD code. See, this frequency division is very, very important for the understanding. I think so. That's why I'm explaining the frequency division code in the previous class. Okay, so this is the 0th step. And the first one, same thing. You need to follow this second line. See, what is the second line? You need to follow this. The first line is over. The 7,50,000 clock cycles is over. Then what is the second line? So write SFD 0 into 3. The pulse LCD E high for 12 clock cycles. I will write this point. See, I will write these points. I mean, I think some members are did not understand it. Now I will write this point. See how you can do the research. I will write this total point. Write SFD is equal to 0 into 3. Of course, the pulse LCD enable high. And of course, for 12 clock cycles. For 12 clock cycles. See, what did you observe in this line? See, this one. I'm underlining the lines. Now the count is 12 clock cycles. In the previous one, how many clock cycles? 7,50,000 clock cycles. But now we have only 12 clock cycles for the next count. But LCD enable is high. That means LCD enable is equal to 1. You need to add this point. You need to add this point. Of course, they're adding the one more point is there, SFD. We will see that SFD. What is that? Okay. 0 into 3 means they're writing something 30. I mean, 0 into 3 means 30. That meaning is 30. Okay. Now we will see that. Now I will show the code of the second line of LCD. See this one. This is the second one. So now tell me how many counts here? 12 clock cycles. Only 12. See, same code. Same frequency division code. You nothing to change for the first one and second one. There is no change of the state increment. If your counts is over, then you can move to the second state. Okay, you can move to the second state. You need to come to second state. And of course, if your counts is not over, you can count increment. Okay, you can do the count increment. It's the same procedure. But one more point is there. LCD enable is high. See, I am adding this point. LCD enable is high. And of course, we need to add the LCD command for 30. So now this is the LCD command 30. According to the manual, for this 3 commands, right? LCD command is equal to 30. And pulse LCD enable is high. See, LCD enable is high. LCD command is 30. And you need to count the 12 clock pulses. Okay. We need to count the 12 clock pulses as per the manual. So same.
Dear faculty, just give a second. Our trainer has some glitch, so he will join again.
So this is the second command. Okay. I think you people are understood how I'm writing the code to follow the following the user manual. Okay. Now see this one. So now see this one very carefully. Same, you can follow the procedure. I mean, you can follow the procedure. What is my third line? Wait 4.1 milliseconds. Or I mean, they mentioned it already, which is longer, which is 4 milliseconds means 2,05,000 clock cycles at 50 megahertz. This is the point. So I will write it. Okay, don't worry. I will write the point. 2,05,000 clock cycles at 50 megahertz. Okay, I think you people are know about it very well. Only one point is there. Is there any point they are mentioned LCD enable is high that they can give any kind of this command? No. In this line, there is no kind of they did not mention any kind of okay. Please write the 0 into 3 or LCD enable is high. They did not write anything. Okay, so we will see what is the code. So same code, you can write like this. You can follow the same code. See, if of count is equal to 2050 begin. Of course, I am writing the rough code. See, they did not mention this. Okay, the LCD enable is high. The command is 0 into 3. They did not mention in this line. So, sir, how can we write it, sir? Simple. If they did not mention it, LCD enable is 0. Just a minute. LCD enable is 0. LCD command is, of course, 0. See if the count is 2 lakh 50,000. Okay. And if your counts is over, next is state increment. State is equal to state plus 1. Otherwise, count increment. Count is equal to count plus 1. See, just I'm writing the rough code, okay? But I will show it. Count is less than or equals. I will show it. I will show the next continuation code. So this is the, this is the next line. So this one. See this one. LCD enable is 0. You can write like LCD command is the 0 also, no problem. And of course the count is, they are taken. Sir, we have some doubts are here. Here they are taken. They are they are told take the 2 lakh 5,000, but now you are taking the 2 lakh 50,000. See, observe that point. They can say wait 4 milliseconds or longer. So you can take much time, much clock pulses also, no problem. Okay, all of you. Yeah, so you can click on the control plus. Now I'm changing the code. Click on control plus. Yes, yeah. So state count 0, state increment, of course, count increment. And you can follow this procedure. Next line. You can follow the same procedure for the remaining lines also, but a few more difficulty lines is there. Okay. I will explain up to final lines. We need to complete this all lines. See, the next line is, of course, they repeated the same. I think, yeah, they repeated the same code. They repeated the same command. I think we have no more, we have no more hard work here. We need to use the smart work, and you can copy the same code here. See, SFD 0 into 3, I think, see, same thing. We need to need to copy the same code. Again, they repeated. Okay. They repeated this second line to fourth line again. See, they repeated this line again. Okay. Second line to fourth line again and again. And okay, I will move to the next line. Yeah, this one. So wait 100 I think 100 microseconds or longer, which is the 5,000 clock cycles. 5,000 clock cycles. Now we need to change the code again. We need to change the code again. Okay. Now we need simple. You need to change this count value. That's it. Everything will be changed here. You need to change the if of count is equal to. You need to change the count here 5,000. That's it. There is no hard work here. If you are done one thing, definitely you can use your smart work. Definitely you will get all things. See, this is also like the previous repeated point, but time. You need to see this. This is the 4.1 milliseconds, 100 microseconds. See, the only changing in the time at 50 megahertz. See, if you use your smart work, definitely you can repeat the code, but you can change your clock pulses. Okay, so here I'm taking the few more counts extra. Okay, here I'm taking the few more counts extra because of why. You know it very well. They are taking weight 100 microseconds or longer. So that's why I'm taking the 8,000. Okay, you can take the 6,000 or 7,000, but we want more than 5,000. All of you. And there is no LCD command also here. LCD enable and LCD command. Yeah, no LCD command in comment line. So up to here, we need to complete this all this process. I think no one have any doubt on this power on initialization. Only one, they're repeated commands. 5,000, 2,000, 0 into 3. They're repeated commands. See, you can see this one. They're repeated commands. You no need to worry about it. Up to here, everyone, you can write your own code. Okay. I think no one have any doubt on this power on initialization. All of you. So anyone have any doubt, you can ask me. I will re-explain it. But if you done one mistake, definitely the mistake is repeated. You know it. You saw that. You know. If you repeat, suppose I am repeated the in my research work, I am repeated the one mistake on this line. Definitely, I mean, in this line I am repeated one mistake, so I'm copying this code to the next line. Definitely the mistake will be repeated here. So this one also. So you have, if you have any doubt, so you can ask me. Anyone have any doubt on this power on initialization? Anyone? If you have anyone, if you have any doubts, so please ask me. Hello, am I audible to you? Can you please anyone give me the reply? Am I audible to you? Yeah, yeah.
Sir,
Yeah, the states is in a sequence. For the sequence order, we are taking this states. Okay, we are taking the FSM, but for the sequence order, I mean, see this, sir, this line, this five mean, I mean, the order. We are started the order from the zeroth line. That's the order. Okay, because of why, sir? Because of this 8 steps, we need to take 0 to 9, I mean 0 to 7. Of course they will be continued, 8 to 13 states. Of course, you, as per your name, it will continue up to the 23 states. Of course it will continue. Okay, as per this order, I am using the FSM. Okay, that's it. uh, yeah, I think no one have any kind of doubts. Yeah, so now we will move to the display configuration. Don't worry, I will send the LCD code. Okay, I will send the LCD code. But as per, if you change the FPGA board, definitely you need to change the few more commands. That's it. I mean, not the commands, few more instructions of this. See, this is the end of power on initialization. Now we will enter into the display configuration. So the first one is over. Now we are entering into the second one, display configuration. So what is this display configuration? I will show it. This one in the starter guide. I think you will get the more clarity. See, in this display configuration, there are 4 types: functional set, entry mode set, display on and off, and of course the fourth one is clear display. See, everything in this manual, you no need to confuse about it. If in this functional set, please write the code of 0 into 28. That means, so before discussing about this 0, I mean this display configuration, you need to see this timing, not this data. You need to see this timings. Just a minute, not this one. No, I will explain it in code. Okay, no need to worry about it. This one is for the data gap. No, here we don't use this one. Okay, okay. First of all, I will explain in the comments and I will show it in the code how the time gap is there between the comments. How can we write it? Okay. See, between the two functional sets, how can we write the code? I mean, there is a time gap. Okay. Yeah. First of all, we will explain about. I will explain about the first type of function set. Function set. Just a minute. So the function set. The function set means they are giving the 0 into 28 command. Sir, what is the 0 into 28 command means? See, the each LCD have 2 lines. The LCD have 2 lines. Each character contains 8-bit. Okay, that is the meaning of function set. But I want the 2 lines of, I want to access the 2 lines of LCD. That is my rule. That is my command. I want to access the 2 lines of LCD. And now I want the each characters, I'm taking the each character 8-bit. Okay, all of you. So this is the meaning of this function set here. This is the meaning of this function set for display operation. Okay, and the second one is entry mode set. Entry mode set in this, I think you people are know it very well. Entry mode set means why I am giving this second command 0 into 06. Why I am giving this second command means in our LCD, we want to start it from the left side. See, we want to enter into the left side. I want to start it from the left side. For the second line or third, I mean first line or second line, that is the secondary. I want to start it from the left. We don't want it from the right. Okay, we don't want it from the right. So I want the information from left side. I want to write it from left side. Otherwise I want to read it from left side, whatever it may be, read or write, read or write, I want it from the left side. Okay, so that's why we need to write this kind of command 0 into 06. So now the LCD will be understand using this command. Okay, the LCD will be easily understand this command. Okay, the this meaning is we need to start it from the left side. Sir, we have some doubt, sir. Okay, they are giving the command of the left side, but how the LCD knows whether it is first line or second line? How the LCD note whether it is first line or second line? I will explain it. Okay, there is also one command, and we will coming to this one, the third line, the third one. This is the entry mode set to decide at the left or right. Okay, on the middle or I mean middle or what? Okay, whatever it may be. Uh, the third one is display on and off. See, display on and off means display on and off means there is a command 0 into 0c 0c see 0c. Yeah, see this 0 into 0c means in this LCD we are writing something, we are writing something. Suppose I am complete, I want to complete my name. I see this is the display on and off means I want the cursor blinking incrementation. See, I want the parallel cursor blinking. Okay, I want the cursor blinking. See, if you have a doubt, so see this one. In this command 0 into 0c, see, turn on the display and disables the cursor and blinking. And you can check with this entry mode set. It display automatically increment of address pointer. Okay. See this, I want to write any character. I parallelly I want two things. So here I want the character and I want the cursor blinking incrementation. I want to of this, I mean, I want to move to the cursor and again I want to write the character. So that is the meaning. Cursor and blinking. Okay, disables the cursor and blinking for this one. And this one is for starting from the left and increment the operation also. Okay, that's it. And of course, the final fourth one is there. Clear. Clear set. I think, yeah. Clear display. So the clear display is the normal one. There is no command. Only clock pulses is there. Clock cycles is there. No, repeated frequency division code. Okay. Repeated frequency division is code is there. You need to take the 8,000, 8 to 82,000 clock pulses. The clear set, sir, what is the meaning of this clear display? Simple. uh, in this LCD, we are totally complete this 32 characters. And the now the clear command, now this clear display command will be activated. Okay, please clear the display everything. They will activate and they're giving this command. Okay, clear this display. So that's the meaning of this 82 clock pulses. I will show the code, how I'm writing it. See, 28. See, 2 into 8 for the function set. And you need to give the time gap of 12 clock pulses. For this one, you need to give the 12 clock pulses. See, and for the each and everything, I mean, 0 into 6, just a minute. You need to give the some time calculation gap of the 12 clock pulses. Again, you can give the 12 clock pulses and you can give the one more 2000 clock pulses. Okay, for each command set. You want to implement this command in 12 clock pulses. See, in 12 clock pulses, again, they want the 12 clock pulses. For the time gap, they want 2000 cycles. I mean, 2000 clock cycles. Okay. So this is the main thing. And of course, they're repeated for this. See, they repeated. Next one is implemented the 6 for 0 into 6. See this one, 0 into 6 for repeated 12 clock pulses. Again, they will take the gap of again they will take the 12 clock pulses and again they will take 2000. See, repeated. Again they will take 2000 for this. So this is again repeated with this command also. Okay, so this is the total information of this what we can call it as this display configuration. Okay, and of course the our theory is over. I mean, of course, almost our theory is over. One more command is there. See, you asking this command. I mean, I will explain, sir. You are given this. Suppose you want it in first line. If you want, I want the start the data or to write the data from first line, or you want to read it from first line. You can give the 80 I mean 80 command. See this command. LCD enable is on, and you want to give this 80 command for the first row. If you want the second row, you can take the C0. Okay. So see, this is the 0 and C. Don't confuse. This is the C0 and this is the 0 and C. This is the C8 or something. I don't know, but C0 is confirmed. Okay. If you want the first line, you can write the 80. You can, if you want the second line, you can take the C0. It will start it from the second line. Okay. Yeah. So this is the first one. And of course, everything will be over. One more is balanced. See, the second one is also over. And one more thing is there. I will show it. I mean, class is over. Okay, no need to worry about it. I will show one example how to print the character. I mean, this is the final, this is the major one. What is the purpose of LCD? We need to print something. Okay, so we are in final step. Okay, just I will write how can we write the code of to print the character. Sir, but how did we know the sir for the 8-bit code? There is one CG-ROM table is there. One CG-ROM table is there. Today I will show it. Tomorrow I will continue. Okay, I will show the output on my FPGA board. See, suppose you want to B character. See this one. You want the capital B. There are capitals, smalls, and of course special characters is also there. Suppose you want to capital B. No, I want capital T. The capital T upper nibble is see 0 and 1 0 1. So you can write like this LCD command. I mean LCD command you can take like this 8-bit 0 1. What is the meaning? 0 1 0 1. Yeah, and you can take the upper nibble 0 1 00. So they can understand this is the T code. Okay, that's it. So this is the total code. I will show you the code. Okay, no need to worry about it. I'll show the code. How can see, but now I'm changing. I mean same code. See LCD command same code, but now I'm changing. This is for U. Okay, this is U character. So that's why there another one is there. Okay, you can continue from there. See, I'm continuing from there. I did 12. I'm taking 12 and 2000 clock cycles. Now I am starting right at there 5B. 5B means see this 5 0 1 0 1. Okay, and this B I don't know. Just a minute. I wanted to show something. Yeah, see this one 5. This here in this one B means see this 1010 means 1011 means B. Say this is the character. Of course, I mean they are wrongly. I mean I'm changing in the middle of the thing. No, this one. Yeah, this is that 5B means. Okay, you can change this one. Sir, you can change this one. If you want to T, you can write like this 5. Of course, what is this 4? You can write the 54. That's it. Now the answer is T. So this is the information about the LCD code. Okay, tomorrow I will show the display, all of you. So this is the today class of the LCD theory explanation. Okay, tomorrow I will continue and I will show it. I will continue and I will show the Spartan 3 board. No, the Spartan 3's board is inbuiltly contains the LCD. Okay, but Spartan 3 board you need to write the data code. I mean, for Spartan 3 that will be you need to write the code of you can take like this. LCD command is first of all you can take like this for 4-bit. First time you can give some time gap, and again you need to take the LCD command remaining 4-bit like this. Okay, that is for Spartan 3. But edge board is you can take directly 8-bit code. That is only for the difference for the Spartan 3 and this edge. Okay, of course it is possible the processor design. So this is the total information about the LCD code. I think no one have. I think if you have any doubts, so please ask me. Otherwise, we will wind up the session. So this is the today class. Tomorrow I will show the output. Okay. I will complete the code. I mean, of course, data code is still remaining. The data pins code is there. That will be very easy. That will be repeated code. Okay, that is repeated code for the as per the characters. If you want to print the different characters, the code, if you can extend the code, that's it. The remaining code will be same, all of you. So this is the total information about the LCD. If you have any doubts, so please ask me. Otherwise, we will wind up the session. Anyone have any doubts?
Sir, this is Raghuveer.
Yeah, please.
Sir, I mean, like Friday, I asked one doubt
Yeah,
regarding this.
Raghuveer, I forgot it. Can you please send me any information about your project? I will give the clarification for that. I mean, I did not listen on that Friday. Sorry for that. I mean, in the meeting, of course. So can you please send me any? Can you can give the any kind of detailed information? I will clarify that.
Yes, sir. Detailed information. I have developed a one code, very long code.
Yeah.
Okay, which I have dumped into some Actel Pro S3 kit.
Okay.
Okay, I have a one system like a data logger.
Yeah.
I need to send the data from data logger to that FPGA board
Okay.
through protocol called like a UART.
Okay. You want to send from the one board to another board? Is this? I
No,
mean, that's
one device to board.
one device. Okay, laptop to board.
Data logger is a machine which uh, have the store the data for release either on or off one.
Yeah,
It will
yeah.
store a data.
Okay, the it will be between the communication between the board and your internal system. Am I correct?
Yes, 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 yes.
Yeah, yeah, yeah. Okay, I understood. Definitely, you want to use another thing. Heard about this kind of project. Uh, tomorrow I will give the clarification. I mean, I know it. Yeah. What's your doubt? I mean, what's your problem? Can you repeat the problem?
What's my problem is I would like to transfer the data from data logger to this this board which I have dumped the code.
Yeah.
Okay, whether I want to make any other board for a UART protocol or shall I design the UART protocol in the same board which I have dumped already?
I mean, if you want to take the another board, is that's your main one, or same? You can repeat it with same board. I could not understand. Okay.
No, I would like to. I mean, that's what my doubt. Can I go for the same board which I already dumped for
Yeah.
again dumping the code of the UART protocol?
Yeah, you can take the one another board also, but you have to take the same board. I mean, what we can call it as you have to take the same board. Suppose you are using the basis 3. Now you
Okay.
can again using the basis 3 another board, no problem. But if you want to change your board, definitely you want to change the as per requirement. There is a few requirements is there as
Yeah,
per
yeah,
the
yeah.
board. If you change the board, definitely the code will be changed. Definitely that will be common everything. Definitely the code will be also changed for the as per the requirements.
No, I mean, like my doubt is not about the changing of the board.
Yeah.
So if I would like to transfer the data from the data logger to that particular board, I
Yeah.
used to use UART protocol.
Yeah, good. Yeah, what is best one? Yeah, you can use that.
Okay.
Yeah.
So for transferring, should I develop a code for UART protocol?
Yeah.
So can I dump into the same board or should I take another board?
No, no, you can take this same board. No problem.
Same board.
Yeah.
Okay, okay. Same board I can transfer the data from data logger to which I have already written some code for the my project. It will be the same.
Yeah, yeah. Is there any kind of document or any kind of detailed information is there? I mean, I will give the more clarification on your, I mean, not
Yeah,
only
yeah.
the, I will give the more clarification of your project. I
Okay, in
know,
this regard, I will send any PDF document.
yeah, I will give the more
Uh,
clarification on for you about the, how can we do the, how can
yeah,
we
yeah.
do the project.
I will show some block diagrams and also.
Yeah, the
Then
block
you
diagram.
have.
Yeah, one block diagram is enough. Block diagram is enough. Yeah, definitely I will do, get the understood.
Yeah, yeah.
Yeah,
Okay, sir. Okay, okay.
yeah. Yeah. Anyone have any doubts about this LCD program? I think no doubts. Yeah, thank you. We will wind up the session. Yeah.